What's up? Welcome to Backend Stuff. I'm Jacob Blitzo. Today we are going to learn how to write tests for our Ecto schemas. We don't have to worry if Ecto works correctly. We can assume that it does since it's a well-tested and heavily used library. But we do want to make sure that our code base is calling Ecto functions correctly. We need to test two things in our schema files. One, the Ecto schema, which is our defined struct and its types. And two, the Ecto change set. This is the code that provides typecasting and our validation logic. In this video, we are going to focus on our Ecto schema. Let's open up our project, Real Deal API. And if you haven't been following along, you can find this in the GitHub repo, and that's in the description below. You'll find the link. And let's start off with just some house cleaning. We have a bunch of generated tests from creating our project and generating our schemas. Let's just delete what we're not going to use today, because we are going to be recreating all these files as we continue on with this test series. So if we just expand test and expand Real Deal API, you're going to see accounts test, users test. Let's just select both those and command a backspace to delete them. And then let's go ahead and expand Real Deal API web and our controllers, and you'll find account controller tests and user controller tests. Go ahead and select both of those, command backspace to delete those. And then let's delete our error views test. Whoops. Command delete. And we're going to keep our test helpers. And I believe that is all we will need. All right, cool. And then in our config files, we're not going to need it today, but we do want our test config. Our username and password need to match our database, so our Docker container passwords. So if we go into dev, you can remember it's backend stuff and Blork Erlang. Let's just go ahead and update those. So backend underscore stuff, and the password is Blork underscore Erlang, and then go ahead and save that. And now when we get to using our database, everything will work and it will be able to connect to our Docker container. All right, let's close that up. And now let's open our account schema. And you can find that in the lib directory and then the Real Deal API, and then it's going to be inside this accounts directory. All right, we're going to learn a cool little trick that'll make our lives easier when we add more fields to our schema struct. We currently have to add our fields to this cast function every time we want to cast a value. And then anytime we want to validate our fields as well, we have to add them here. Right underneath our schema, let's just make a new function, and it's going to be private. So def p, and we'll call it all underscore fields. And what's cool is, so if we go ahead and just call our schema, so we can do this, double underscore, and then all caps module double underscore. This is the same as writing out Real Deal API .accounts.account. The nice thing about using this module variable is if we ever refactor and rename our module, we don't have to go all the way through the file and find any instance that we used it. So it will always call our Real Deal API .accounts.account module name instead of having to type the whole thing out. So that's a nice little shortcut to know. And then if we go dot double underscore all lowercase schema double underscore, and we can pass in an atom here. So colon called fields. And what this will do is it will return all of our fields. So we can now call this function and it will give us all of our fields. So instead of passing in a list here, we can just call our new function. So down in our change set, delete that list where we had email and hash password. And all we're going to do is call our all fields function. I should also say that the double underscore schema, this references our schema accounts right up here. And then the atom fields just returns all fields. And we'll use this a little more. It can take 2 arguments. So we can pass in a colon, so an atom for type, and pass in the field that we want to know the type of and get that back. It's super useful. But if I were to command click this, it just takes us up here. So it's pointing to our account schema. And then, so down here in our validate required part, we can also call our all fields function. So all underscore fields, there we go. And now let's save this. I don't know about you, but I think it's pretty freaking cool. It allows us to update our Ecto schema, and our change set now will dynamically update based off the fields we add to our schema. So we never have to update in 2 spots, because whenever I do, I always forget to update my cast function, and then I test it and I'm like, well, why isn't my new argument being added to my database table? And then I remember I have to update the fields in the cast function. And now we don't have to worry about that. But let's go ahead and test this now. So let's make sure our database is running. So open up Docker. And mine is not, so I'm going to press play. And now it's running, and we can close this. And let's pull up our terminal. And let's cd into our project. Mine is in Documents, Develop, BS, and then Real Deal API. And let's run our project. So mix space phx.server. Okay, and now we're running. Let's pull up Hopscotch. And we need to just create a new account so we can test that our refactor works. And that's going to be just our API /accounts.create. And then in our body, let's go ahead and create client3 real password. We'll keep all this information the same. And let's go ahead and just hit send. And all right, so we got an error back, and it says that ID can't be blank, inserted at can't be blank, and updated at can't be blank. If we can't have all of our fields required, so our ID, inserted at, and updated at are values that are not actually created until they're inserted into the database. So we're missing those, but they are fields that exist in our schema. So timestamps is that creates inserted at and updated at, and then our ID is automatically generated for us as a primary key when it gets inserted into the database. So how can we ignore these values but still use our cool new refactor? Well, we can create a constant list and add all the fields in there that we want to not include in our required list. So right above our schema, let's just go ahead and create this constant variable. So we can do that with an @ and then call it optional underscore fields space, and then we'll just make a list here. And the first item is going to be our ID. The second item is going to be inserted at. And the third item is going to be updated at. All right, so now we have our list of our optional fields. How do we remove them from our all fields function call? So down here, our validate required, it's taking a list of all of our fields, and we want to remove our optional fields. So we can just subtract our optional keys from our list of all fields keys. So if we just do a minus and then call our optional fields variable name, that will now remove these 3 keys from the list returned here. But just to verify, let's go ahead and save this. Okay, so now let's go ahead and test this again. Our server's still running, so let's just go ahead and create client3, same password. We'll keep the rest of the information the same, and let's send it. And there we go. So now our validation's working correctly. We're requiring our email and our hash password, but not the ID inserted at timestamp and updated at timestamp. So our refactor is working, which is pretty cool, right? And now we can actually implement this in all of our schemas as we create them. Now it's time to create our first test file. And we're going to create a test file for our account schema. So let's go ahead and go down to our test directory, and we want to expand the Real Deal API, and let's make a new folder. And we're going to call this a schema. And then inside our schema directory, let's create a new file, and we're going to call this account_test.exs. And then let's create our module name. So def module, and it auto completes, but you want it to be real deal API.schema.account test. And then we need to use xunit.case. All right. So from the beginning, Elixir was developed with xunit, and it's a test framework, and it's part of the core library in Elixir. This means you can write effective tests without needing to bring in other libraries, which is pretty cool. Common macros and functions we're going to use. One is called assert, and it basically just makes sure the condition to the right equals true. And then we'll use refute, which makes sure anything is nil or false to the right of it instead of true or truthy. Now we're going to just need one alias for today, and we just need to have access to our account schema. So we're going to do realdealapi.accounts.accountStruct. And the first test that we are going to write is going to just verify that our schema fields and types are what we expect them to be. So let's first make a keyword list with our field names and the expected type for our account schema. And we're going to do that just right here at the top as a constant variable that we can grab. So at expected underscore fields underscore with underscore types. And this is just a list. And we're going to just have our keyword list, a bunch of tuples with our field name, and then followed by the type. And our ID is a binary ID. And then close that tuple off. And then our next value is email. Oop, forgot the curly brace. And then we have email. And this type is just a string. And we're just going to go down this list. So another curly brace, and then we have our hash password. And this is also a string. And then we can't forget inserted at, which is a naive date time. And then we have our updated at, which is also a naive date time. If you don't know what a naive date time is, it is basically date time without keeping track of the time zone. So you're just assuming, I have a typo here, you're just assuming that the time it's created doesn't matter what time zone it's in. So like in our case, it'll be probably whatever time zone our server is set up at, so our Docker container. And so now we have this list of our expected fields and types, which I got just straight out of our schema right here, right? So we have our email, hash password, and this relationship has one. We don't have to worry about user, because user, when we write that test, has an account ID that's how the relationship is made. It's not made the other way around. And then timestamps is inserted at and updated at. That's just a nice built-in function with Elixir. And so this is what our schema looks like. Now that we have our expected fields and types, let's check them against the actual fields and types inside of a test. So when we write a test, all tests have to be inside a describe block. And a describe block allows us to pass a description for a grouping of tests. And it also lets us share a setup, which we'll get into in later videos. but all tests need to be inside of a describe block. So I'm going to just write describe space, and then you can write a description of what these tests are going to be for. And in this case, it's going to just test our fields and types. So fields and types, and then do and end. And then you want to, now we can write our first test. And here's where you would write the description or the function we are testing. So in this case, we're going to say test. It has the correct fields and types. And then we need a do and an end as well for this block. We want to create a list that is in this same format of our actual fields and types, right? So let's make a variable called actual underscore fields with types. And then we can set that equal to, and I'm just going to return for readability. And now we can cycle through our fields, okay? So we can do a for loop here. So we're going to do for, and then field is the variable or parameter we're filling, each iteration through the loop. And we just need to do a less than dash. And then we can call our account schema, and we can use the underscore lowercase schema underscore again. So we can do underscore schema underscore, and then we can pass in an atom. And this is just like we did in the schema. It's just colon fields. And now we're going to get all the fields back, and it's going to loop through them. And then we need to get the type of each field, because fields is just returning a list of atoms right now with just the keys, the keyword keys, but we don't know the type. But the underscore schema can take two parameters. So we can just easily set a variable here called type and say it's equal to, and then account dot underscore schema, and then underscore, and then opening parentheses. And now we can pass in two arguments here. So an atom called type. And what do we want the type of? We want it of the current field we're on as we're looping through our list of fields. And there we go. So now we have our current field and type, and we can just return this into actual fields with types list. And we want it to be in the same order as our expected fields. So it's just going to be a tuple with field as the first parameter and type as the second. And now we will have a list that is in the same format. So now we're going to use the assert keyword, and that whatever statement is directly to the right needs to be truthy. So it needs to equal true or false. And if it equals false, our test will not pass. So we want to just do assert and then actual fields with types. And then we want to make sure that it equals our expected fields with types. Now for the comparison here, both lists must be in the same order to pass, which we actually can't control the order of our lists. We don't know what they'll come back as. But if we use map set.new, it will only take the elements being present into consideration because sets are unordered. So all we have to do here is do map set.new and just go ahead and pass these lists into that function, and then do the same thing to the expected fields with types. So map set.new and just pass that in to that. And then if we save it, let's run this test. So let's pull up our terminal. We got a Control-C twice. And now if we run mix test, it will run our test. And let's see what happened here. We have a syntax error. Naive type. All right. It looks like I just forgot a comma. All right, so save that and let's go back into our terminal and run mix test again. Variable expected fields with types does not exist and is being expanded to. Oh man, I am tripping. All right, so it's looking for expected fields with types. To call that constant up there, we just have to put an @ symbol in front of that. All right, third time's a charm. Let's mix test. And there we go. So our test had 1 test and 0 failures. So that means it passed. And now just to show you that it's working the way we expected, if we go to our account schema and let's just comment out our hash password and save it, and then go back to our terminal and run mix test, now we'll get a failure and it's going to say that our code doesn't match. So our left side is not equal to the right. So our left side is actual, right? And if you notice here, we just go straight to email and there's no hash password. And then it's highlighting hash password on the right. So that this value isn't matching the left. So we know exactly what's missing. And we can now go to our account schema and we know it's missing the hash password. And we'll uncomment that, save it again, and then run this test and we'll have a successful pass again. All right, so I have a challenge for you guys now. You need to refactor our user schema change set, the cast and validation code, the same way we did our account fields today. And then also write a test for the user schema to make sure the fields and type match the expected outcome. I will have the user schema and tests in the GitHub repo. So if you want to just double check what you're doing or just see the answers, just click on the link below. And as always, if you need help or want to check out the solutions, check out that GitHub link in the description. And if you have more questions or just want to hang out and chat, join my Discord server, Backend Stuff. That link is in the description as well. If you want to learn how to build scalable, production-ready APIs, hit that subscribe button now. See you next time.